Hi guys, so today you are going to be learning about metric measurement. The first thing, of course, we always ask is why do we use metric measurement in science? And there's a good reason for that actually. Here in the US we use the standard measurement, and unfortunately in that measurement system it's kind of hard to convert things. So when we're trying to transfer from 12 inches to a foot, 3 feet equals a yard, and I can never remember the number, but 5,000 and something feet equals a mile. And then you look at even ounces or pounds or masses or liquids, and all of those conversions are 16s and things like that. And it's just really kind of hard to convert to. But here in science, we use metric measurement. And the reason we do that is because it's easy to convert. Everything that we do in metric measurement is a multiple of 10. It's that easy. All right, if you take a look at this is a metric conversion chart. And so what we're doing here is, again, we are doing everything by tens, right? If we're going down, then we are converting from to a smaller unit. So all you're going to do is move the decimal point over. So if you're going from the basic unit, for instance, a gram, and you're going down to a decigram, you're just going to move that decimal point over from 1.0 to now being 0.1. And then if you're going to centimeters, it's going to be 0.01. And then down, not meant to be meters, but grams, milligrams, then you're going to go down 0.001. So it all converts down. Now, if we're going upward, we're going to go to deca and hecto and kilo. We typically go just to kilo. We kind of leave deca and hecto out of it, but we go from the basic gram, again, in the unit, and then we go up to deca by multiplying by 10. So 1 gram now equals 10 grams. Then hecto would be 100 grams, and kilo would be 1,000 grams. All right, so the first thing you're going to measure is mass. And in this mass lab, you are trying to find the mass of different objects. Those can be objects from around the room or in your backpack. And you're going to shoot for certain sizes of mass: 1 gram, 5 grams, 10 grams, 20 grams, 50 grams, 100 grams, and 200 grams. Now, this can be one single item, or you can use multiple items to do this. On the 1 gram, you do need to be at 1 gram, maybe 0.1 on either side, but at about 1 gram. The rest you can be within 1.0 grams. Before you measure any items, make sure that you have zeroed out the machine by pressing that little button that puts it to a 0. After you have done that, go ahead and add in any of your items to get to the right amount. Make sure you're on grams too. Then here at the bottom, you're going to circle the best metric unit for each. So for your mass, should it be milligrams, grams, or kilograms? Amount of spices in a batch of cookies, same, and the mass of 10 pennies. All right, next up is volume. This is the volume lab. So you're going to actually first off start by practicing reading different types of liquids inside of a graduated cylinder. If you take a look at this is showing you 4 graduated cylinders. The first one I'm going to walk you through. The rest I'm going to give you a little bit of a hint on. So the first one, it actually shows, you can see that there is 1 milliliter in the bottom, 3 milliliters in the middle, 5 milliliters at top. So you need to figure out what is that measurement that it is showing you, how many milliliters that is. Then the next one, please note that it goes 5 and 10. And the one after that goes 25 and 50, and the one after that goes all the way to 100. So each one of these graduated cylinders starts at 0. So again, that very first one, you're going to go from 0 up to 4 milliliters. But that next one, it's a little trickier. It's going to go up to it goes up to 10, but you need to figure out what is that amount of liquid in there when you're going from 0 to 10. And the next one again, 0 to 50, and how much is in there, and 0 to 100, and how much is in there. For this next part, you're going to be in the volume section of the classroom, and you are going to be measuring out how many drops of liquid it takes to go up to certain amounts on the graduated cylinder. The first thing, though, I want you to know is that when we're reading a graduated cylinder, there's a couple of rules. Number 1, you need to make sure that you are at eye level to the graduated cylinder. The reason being is that you can't really tell the distance that it has gone on the sides if you can't see them straight on. So what you need to know is that water is actually attracted to the sides of a container. And so what happens is it actually crawls up the sides of the container, and that's one of the reasons that as you are looking at this, you need to get to eye level 2, is because you need to see the bottom dip. So you're going to notice that it actually dips down in a graduated cylinder. So you need to actually measure from the bottom of the dip, not where you see the highest point on the sides of the graduated cylinder. All right, so in this part, you're actually going to measure out how many drops it takes to take water up to a certain measurement on the graduated cylinder. So you're going to need the beaker of water, you're going to need a graduated cylinder, 10 milliliters, and you're going to need a pipette. In order to gather water into the pipette, just squeeze the bulb, take it into the water, and release, and it's going to pull that water up in. Now you're going to take this over, and I want to point out what you're going to do. You're not going to drop, drop, drop. This is drop, 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 and count how many drops it takes. You're going to take that over here and you're going to go drop 1, 2, 3, 4, 5, 6, 7, however many it takes until that meniscus, so that bottom of that curve, reaches the number 1. After that, you're going to go ahead and do it until the number 2 and then up to the number 3, recording how many drops it takes for each section, starting at 0 after each section.
Yeah.
All right, so as a reminder, again, you are going to want to measure how many drops it takes to go from 0 milliliters to 1 milliliter. Start over, go from 1 milliliter to 2 milliliters. Start over, go the number of drops it takes to go from 2 milliliters to 3 milliliters. All right, the last section is on length. And again, you can do these in any order. It doesn't matter. Just take your time going through each of the stations. And a lot of this length section can actually be done at home. So it's very important that you get the mass section done and the volume section done, as well as a couple of these items done here in class, such as number 11, where you have to measure between 2 pieces of tape in the classroom, or where you have to measure each other over at station 6. Everything else can be done at home. Number 1, you're just converting or explaining the abbreviations. MM equals what? In this case, it's millimeter, so you need to complete all of those. In section or number 2, just convert from 1 meter to how many centimeters? How many does it take? And do a couple of those. In section 3, you are telling me which one is higher in converting from different measurements. On the next one, you're going to have to use a measurement ruler, so a metric ruler, and we've got a bunch of those here in the classroom. Other than that, you can go ahead and use one at home or your own if you need to. You're going to need to find the length of an unsharpened pencil, and then your measurement. So again, number 6 will be over in a section of the room. 2-meter sticks lined up on the wall. You need to measure each other's height. Then you need to find the 2 pieces or measurement between the 2 pieces of tape on the floor. And then you also need to go ahead and measure your shoe. Leave it on. No stinky boy shoes allowed. So measure your shoe, and then you're going to convert that. And the last 2 sections, so one of those you're going to measure a stack of 10 pennies. Be specific. I'm telling you, I know exactly how many it should be, and then you're going to convert that into how many 100 pennies would be and how many 1,000 pennies would be, or how much the length would be. And then the last, you're just circling the best metric measurements for length of an eyelash, a flagpole, a strand of spaghetti, and the distance between Casa Grande and Phoenix. Have a great day, and we will see you again soon. Enjoy the metric lab. If you have any questions, email me. You know how to get a hold of me. Thanks.